This is how I did the facial detection for the ENME489Y class. So here I have a scene from the movie Nightcrawler, where you can see the main scene up in the top right corner here, the original, the scene with the faces blacked out with the confidence intervals printed above, and then also the scene in the bottom left with the faces actually blurred out. So now to walk through how I actually accomplished this. So first off, we got to import multiple necessary libraries: numpy, argparse, cv2, and imutils. Argparse is a new library we used, which is to create a multi-line argument for the Python script, where we use it here to feed in each of the different things we need, which are the prototxt, the model type, the confidence interval we need, and the video that's actually being read. So we capture the video from the video feed. We then capture it, check the frame, and then here, in this first one, is the main point of interest. We find out how long the video is in terms of FPF frames. So we count how many frames there are, and we decide the height and width value on the first one. And then to determine the number of frames, it's just 1 minus the amount of counter. Pretty simple there. And we print the amount of frames to terminal. Then we just define the video output so that we can actually display the video to whatever we're hearing here. I renamed these, if you notice. It's job black, job, and job blurred, but actually in file it's going to print as facial detection video.mp4. Next, we load the model, and then we apply facial detection to each individual frame. So while the frame that we go frame by frame, so while we're still in a frame that's less than total number of frames, we count it off each time. We check that there's a image there, we read it, and we have it there. So we're reading the image frame by frame, and then we figure out which frame we're in, and then we print the progress. Initially in class we just did a progress by number of frames, but I decided just to change it to a percentage because that is easier to read and easier to understand as I'm going through and troubleshooting. So then we use the construct blob with the cv2 blob functionality, which creates a blob of potential faces on an image, and it decides like what looks like an image and what could be, and it applies a confidence to that. So using that confidence, which is here, detections.shape2, we decide each of those detections, we look at them and we say, okay, we want to find out the confidence. So we go into detection and we're like, okay, I of I, which is the range of detections in the shape, we say that's the confidence we're looking at for this individual frame, for this individual potential face. So then if that confidence is greater than our assigned confidence, what I failed to mention earlier is that our default confidence is generally 0.5, but I found for some of the frames that I had here, it seemed that 0.3 or 0.2 was even better for actually picking up all the video faces. So then after that, we define a bounding box based on the height and width of the detections, and then we define the start x, start y, end x, and end y, which are the limits for these boxes around the face that you can see here, that they're defined based on the detection. So then we draw the bounding box and provide the probability that this is a face based on a text. So the text will just format the confidence as a percent, which you can see up here. It's like printing 99 for whenever it's on Jake Gyllenhaal's face and Riz Ahmed's face, depending on if he's looking at it. It's higher, but sideways it's lower, like 20% here. And even still, you can see actually it doesn't even pick it up when he's completely sideways, which I've noticed is a failure of the algorithm. But I think that's something just with the thing we're using, and I might have the confidence too high to pick that up. And then next, we define a rectangle. This is just a red rectangle you can see on that outline, and then we put the text on top of the rectangle, which is the confidence, and then we will also put a black fill-in on that using this. On the other hand, if we want to just blur the face, as is used in a lot of ways, we have to use we create a face area, which is the same area, start x and y, start end y and x, but then we blur that face area. I used a pretty high kernel size of 55 because I found that to actually blur the faces rather than lower kernel sizes, which didn't really blur faces. And we go for each range in that face area, we just apply to the image. And then we rate the frame to file, and then we destroy the thing. So I showed you working on this one, and I want to also show that I tried it on a second version, where it also worked, on another scene from another movie. This is from Goodfellas, where it also applies the same idea. The original scene, the black boxes, and then the blurs. Something I noticed again is that it doesn't really pick up side views, and if the face is in the background and a little dark, it's not going to pick it up as well either.